No, you're not.
Do you have any homework questions?
I do. It's 9.37 minus 8.
Which Mindscape?
10.
10. So one of these is off the screen. This is a normal distribution. It's shaped like a bell. This one is skewed to the left. Instead of having the peak in the middle, the peak is off to the left. So that's skewed to the left. And then this is a bimodal distribution where you have two peaks, two bells. So what do we have to answer? What's normal? Let's see. Figure 1 is a normal distribution, figure 2 is skewed, and figure 3 is bimodal. Estimate the mean. I don't know how good an estimate we can get, but let's check. So the mean would be when you add up all the numbers and divide by how many data points there are, and it should be toward the middle of a normal distribution. Let's see if we can tell the scale here. It looks like these go by fives. Let me just double check. Okay, I think they go by fives. So right in here, between these two, right around in there, that would be, if we're going by fives, it would be like 95, 90, 85. Let's try 85 and see what it says. That wasn't close enough. Did anybody get this one? We want to see. Well, I'll try 90 once. $90 didn't work. 85 didn't work. Let's try. I have 2 chances left, right? Let's try. I should try 92. A little bit more than 90 once. Nope. Did anybody get this? 80. It is 80. Okay. Thank you for telling us. Okay, so 80 would be, this is 50, 55, 60, 65, 70, 75, 80. Oh, so right in here would be 80. That makes sense. Good job. Anybody have any other questions? Yes.
Same chapter, 24.
24. A student received the following quiz grades. What is the lowest score a student can receive on the next quiz that would raise the student's mean grade? So, do you have different scores?
It's different scores, but
Yeah.
just understand the process.
So the process would be to find the mean. So let's go ahead and find the mean. So your mean might be different than mine. So I'll add these all up and divide by 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So find whatever your mean is, and then to raise your score, you need to be above the mean. To lower your score, you would be below the mean. So the mean on this data set is 79.125. To raise the score, I need to have at least an 80 then, for this student. So you need a little bit more, okay? A little bit more than the mean to raise the mean. Anybody have any other questions? Yes?
Could you do 9.1?
9.1? This is a kind of a trick question. Suppose .com entrepreneurs want to know what percentage of people use the internet. They send a questionnaire to all email addresses asking whether the recipient uses the web. What percentage of the respondents is likely to say that they use the web? Anybody get this one? It's 100.
Yeah, I have an email that I use.
Exactly, because they wouldn't answer the question if they didn't go to their email. And they wouldn't, if they go to the email, they use the internet. So it's kind of a trick. The point of the question is that it's probably not a good way to find how many people use the internet to ask by using the internet. Any other questions? Yes.
The first quartile is just the mean of the first half of the data set.
So we were going to look at some more problems getting the first and third quartile and make sure you know how to do that. Do you want to look at a particular homework problem, or should we just go to the...
Well, there's different values probably for, like, for example, 0.3. You have that
Okay.
for 9.2 for 0.3. Okay, 0.3, I mean, as the asks.
So you have different numbers. So there's 22 people. We're going to find the first quartile. So first we'll find the median. So since there's 22, that's an even number, so we're going to have to average the middle two. So let's look at the middle two numbers. 1, 2, 3. So the 11th and 12th. So for me, those are both 25. So the median will be 25. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I'll put my cursor there to divide the data in half. So we have the smaller 11 numbers and the larger 11 numbers. The first quartile is the median of the smaller 11 numbers. So since there's 11 numbers, I can't divide them exactly in half, but that's okay. We just take the very middle number. So the very middle number will be the 6th number. So there'll be 5 numbers smaller, and then 5 numbers between that number 6 and the cursor. So 22 has 5 numbers below it, and then there's 5 numbers until you get to where I place the cursor in the median there. So 22 is the first quartile for this. The third quartile will be the median of the larger 11 numbers. So I'll get my cursor back in the middle, dividing them in half again. So I need the 26. 26 will have 5 numbers bigger than it and 5 numbers between the 26 and where the cursor's at. So 26 would be the third quartile on this data set. So the medians of the smaller half of the numbers, and the medians of the larger half of the numbers are how we get the quartiles. Just submit this answer once. Let's go ahead and practice some more first and third quartiles. So here's a list of some numbers. I've already arranged them in order. On your quiz, they won't be arranged in order. So the first thing you should do is put them in order. And then after you put them in order, count and make sure you didn't miss any. So here we have 17, 21, 27, 82, 82, 85, 87, 90. Go ahead and list the median, please. So go ahead and list the median, please. This time there's an even number of data points, and so you'll have to average the two middle data points. 1, 2, 3, 4, 5, 6, 7, 8. So the two in the middle I'll average to find the median. Well, that's pretty easy. 82 plus 82 divided by 2 is going to be 82. So when you have even number of data points, you have to average the two middle ones to find the median. And we did that with the houses and with the grades on Monday. Well, that divides the data set in half. And now you find the median of the bottom four numbers and the median of the smaller four numbers and the median of the larger four numbers to find the quartiles. So the four numbers are even. So to find the first quartile, you have to average the 21 and the 27. You should get a number between 21 and 27. If you didn't, you did something incorrect. So add the 21 and the 27 first, and then divide by 2, you get 24. So the first quartile here is 24. And that just means that 1/4 of the numbers are smaller than 24. And you can look and see, yeah, 1/4 of the numbers, that's just two numbers. There are two numbers smaller than 24. The third quartile, you should be averaging these two, 85 and 87. It comes out to 86. And that's just saying that the 25% of the numbers are bigger than 86 and 75% of the numbers are smaller than 86. I wanted to show you a data set where you had an odd number of numbers because it seems like we keep finding data sets with even numbers, even amounts of numbers. So let's just write this list down again and we'll put one more number on the end of it. So we'll find the median in the first and third quartile by just writing these numbers down again. 17, 21, 27, 82, 82, 85, 87, 90, and now we'll add 93. So go ahead and write the median down again. So the middle number is the median, and this time there is a middle number because there's 9 numbers. So the number in the middle is this 82. So when you have an odd number of numbers, the median's easier to find. You don't have to do any averaging, you just pick the middle number. But now we have to find the first quartile and the third quartile, and where do we draw the line? Well, you still draw the line to divide right here. It's just that the line crosses out the 82, and the 82 is not included at all as you go ahead and find the first quartile, and it's not included as you find the third quartile. So when you divide the odd number of data points in half, you actually draw a line through that median, and it's not included in the smaller half of the numbers or the larger half. So first quartile, this time we're averaging 21 and 27. That's what we did last time, so it's 24. Third quartile, we're averaging 87 and 90, so that did change. $177. That I forgot to divide by 2. If you don't get a number between what you're averaging, you made an error. 88.5. So the first quartile is the median of the smaller set of numbers. The third quartile is the median of the larger half of the numbers. And if your median was just a single number and you didn't have to average, just cross that number out instead of drawing the line between the two numbers you averaged. Anybody have any questions?
Why is it first, third, fourth, now?
So quartile means quarter.
Yeah.
So 1/4. If you put the 24 here, 1/4 or 2 of the data points are less than 24. And if you put the 88.5 here, 3/4 or 6 of the data points, in this case 7 of the data points are less than 88.5. 1, 2, 3, 4. I'm not counting it. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 data points are less than. So 3/4 of the data are below the third quartile, meaning 3/4, and 1/4 of the data points are below the first quartile, meaning 1/4. Did that answer your question?
Oh, yeah.
Any other questions? Well, we're going to go. Oh, before we go on, one of the students stopped by and showed me that your class activities don't always show their description properly if you don't have the browser that I'm using, or maybe on your phone. Sometimes they don't show properly. So if that's the case, then you might have had a problem trying to figure out the instructions. So I decided to drop one more class activity. Instead of dropping 3 class activities for the semester, I'll drop 4. And hopefully if you had some problems figuring out what the directions were saying, then that will help with that. We are in section 10.3. The section 10.3 is titled Faring Well or Welfare, Money Matters. So I thought it was kind of a fun section. We start with a question from the author. Adam and Eve invest 1 penny in a bank account paying 3% compounded annually. How much money will the account hold after 1,000 years? Will there be 10,000, 100,000, 1 million, or $1 billion? So go ahead and write down your guess, and we'll come back to that, okay? We'll figure out how to tell what the compound interest is and come back to the answer. 10,000, 100,000, 1 million, or 1 billion when you invest 1 penny for 1,000 years at 3% compounded annually. Well, Ben Franklin called compound interest the force that will turn your lead into gold. So, force that will turn your lead into gold. Here I have a book by Dave Ramsey. How many of you have heard Dave Ramsey on the radio? Anybody? Yeah, I like listening to Dave Ramsey. He's pretty funny, and he has a lot of good advice. He calls his course Financial Peace University, and it is, I think, a good name for the course, because if you get your money under control, you do have a lot more peace. Did you ever think about how much money you're going to earn over the course of your lifetime? I would say more than $1 million. So it would be well thought of on your behalf to think about where that money is going. Where are you putting that $1 million instead of just being reactive all the time? Oh, here's a bill, I got to pay it. My car broke, I got to pay it. Think ahead, okay? And then you can have some financial peace instead of just reacting to the circumstances. Well, talking about compound interest, we have here, I'm going to make this bigger now. We have here the story of Ben and Arthur. Ben saved $2,000 per year at 12%. Oh, they both do. Ben starts at age 19 and stops at age 26. So Ben saves $2,000 every year for 8 years. Or how many years is that? I think it's 8 years, because we're counting the year. Yeah, we're counting the year he turned 19. So Ben invests eight times 2, or $16,000. Arthur doesn't start right away, but he puts in a lot more money. When Arthur is 27, he starts putting away $2,000 every year, and he's very careful about that, and continues putting away $2,000 every year until he's 65. So Ben never put in any money after he hit 26. Arthur, on the other hand, starts when he's 27, but then does not quit. Who do you think has more money in the end? This is at 12% compounded. It doesn't say what it's compounded, but it's 12% per year, which would probably indicate in this market a mutual fund, although back when this book was written, you could get savings and CDs for that. Who do you think comes out ahead, Ben or Arthur?
Probably Arthur.
Probably Arthur, because he puts in, let's see, well, like almost 40 years at 2,000 each. That's almost 80,000, whereas Ben only put in 16,000. Let's take a look. When they both turn 65, Ben has over $2 million, and Arthur has $1.5 million. Both are pretty good, but Arthur never caught up. One of the things that makes compound interest so powerful is the number of years that you invest, and that's why I'm telling you this now, because when you get out of college, who expects to make more money when you get out of college? Anybody? Okay, I hope so too. So when you get out of college, if you invest $2,000 a year, then it'll have a much bigger payoff than if you wait till like you're 30 or something like that. And when you get out of college and you get your first job and you start making more money, if you put that aside at that point, it doesn't feel as bad as when you put it aside after you've gotten used to spending it. So put it aside right away before you get used to spending it. You can make a huge difference in your savings at the end. So one of the things that makes compound interest so powerful is the number of years you invest. And we'll go ahead and work that out in a little bit and see why that works. Another part of making compound interest very powerful is the interest rate. If you invest $2,000, oh no, this is $1,000, a one-time investment for 40 years. At 6%, that $1,000 grows to $10,000, which is great, 10 times as much. At 12%, it grows to $93,000. And at 18%, it grows, that $1,000 would grow to $750,000 at 18%. So this is why people try to invest in things that are a little riskier but have a higher interest rate overall. And that's why the stock market is so powerful, because in the stock market, you can get a mutual fund that distributes your risk. So a mutual fund, you don't just invest in 1 or 2 stocks, you invest in hundreds of stocks with a small amount of money. So you just have a few cents in each stock, a little bit goes up, that's great, some goes down, it's not so damaging. So 12% is not unheard of to get on your mutual funds on an ongoing basis. It's still a little high. If you had been investing in the late 70s during the Carter administration, there was terrible inflation, and you could invest in the most safe investment in the world, the United States Treasury bonds, and they were paying 17% interest. If you could have got that for a 30-year Treasury bond, you'd be just doing amazing. You weren't born yet, so you have some excuse for not doing that. Okay. Your Financial Peace University talks about some ways that you can cut out and save a lot of money, and what that money invested would look like over the decades. So here he has you cutting out cigarettes, which aren't so popular as they were when this book was written. But gourmet coffee certainly is still popular, and you can save a lot of money by switching to McDonald's, which I find pretty good myself. Not eating out, that saves a lot of money. There's a lot of ways you can save money. One of my friends was a real cheap person, actually. I would call her cheap. We went camping with her family, and our family went camping. Well, her husband Greg came back from the vending machine eating a bag of potato chips. And, just minding his own business, eating his chips. His wife Kathy, she looked at him and she said, "Well, Greg, you can eat those chips and wear them on your gut, or you can invest that 75 cents and make some interest." So I don't want you to get that cheap, okay? And that was actually kind of mean, I thought, too. But you can save a lot of money. My dad was a truck driver, and he was real cheap. He wanted everybody on the CB to call him reindeer, but they won't call him reindeer, they call him penny pincher. So my father's going away college advice to me was, now remember, honey, 2 cheeseburgers cost less than 1 Big Mac. Okay. So I grew up learning how to pinch pennies. Well, let's go ahead and see how this interest works, so you can have some money saved. So let's see the interest formula for compound interest. This is what you'll need to be able to do on the quiz. So the formula is A equals P times 1 plus R divided by N raised to the NT. And I actually do put that formula on quiz 3, but of course you need to know what everything in the formula stands for so that you can use the formula. So we have the A. The A is the amount after T years. T is time. T is time. P is principal. So that's your initial investment. Then we have R. R is your interest rate. As a decimal. So when you have your interest rate, you're going to need to write it as a decimal, and then you'll put it in your formula. So if you had the 3%, that would be 0.03. You move your decimal place 2 places to the left. So the 3% would have had a decimal right here, and you move your decimal 2 to the left. So if you had 2.25%, you'd move your decimal 2 to the left, so 0.0225. Okay, so that's how you change your percentage to a decimal. We have one more number. N is number of times number of times of compounding per year. So if you're looking at compound interest compounded quarterly, that would mean 4 times per year. Okay, if you were compounded monthly, then that would mean 12 times per year. So the N is 12. So there's some examples of N. You can have all different kinds of compounding. I was all excited the first time I got a CD from a bank. So we had some money set aside that we weren't going to need for a while. So I thought, well, I'll put this in a CD and get a little better interest rate than just in my savings account. And I went to the bank and I got the CD. And as I was leaving, I said, "Oh, and how often does this compound?" And they said, "Semi-annually." I said, "Yeah, but it's a 6-month CD." So basically it wasn't compounding at all. Okay, what is compounding anyway? Does anybody know what compounding is? Yes, what is that?
Interest is added, then the next interest for the next term is based off of the new value, how much interest has added.
Nicely explained.
Yeah.
So your interest is
Making money off of money.
Yeah, your interest is earning interest. So if you just are compounding every year, the interest is calculated at the end of the year and put in your account. But if you're compounding every quarter, then the interest is calculated every 3 months and put in the account, and then you get interest on your interest. So compound interest is interest on your interest. Let's look at some examples. Let's look at an example of something you could do. So suppose you invest $2,000 at age 23. So when you get out of college, hopefully. You leave it until you are 65. Okay, so 42 years. Let's say you are earning 10%. Compounded quarterly. How much do you have at age 65? How much do you have at age 65? So let's go ahead and use this formula and figure it out. If you have a scientific calculator, you can put the formula in all at once, but you'll have to be careful to put parentheses around your exponent if you do that. Okay, so use parentheses there if you do that. I'll show you how step by step in case you don't have a calculator that does everything all at once. So first we have to figure out what all the letters are. We're going to calculate A, so we can just write the A down. What number in the word problem is the P? Which number is the P?
2,000.
Good. So this is the P. And what will the R be?
10%.
10%. So 10%, when we put that as a decimal, 0.10. And what would the N be?
Quarterly, so 4.
Yep, N is 4. One more letter, T. What is T?
42 years.
Good. So we identify everything we need from the formula for all the letters, and then we can write those down. So we have 2,000, parentheses, 1 plus 0.10 divided by 4, parentheses, 4 times 42. So let's write down the order that you do these steps. Okay, so multiply out the exponent, the n times the t and the exponent there. So n times t, 4 times 42. So 168. Then do the part, the 0.10 divided by 4. That's the r divided by n. So 0.025. Then you do the adding inside the parentheses. So this would be 1.025. Then we add that up. Oops. Only now do you go ahead and apply that exponent. So that exponent was waiting around until you did all those steps. Now you can say 1.025 raised to the 168th power. .62. I have 99, so you want to keep a lot of decimals here. If you round off, you can think of it as truncating, losing money. So I'll write down all these decimals. Instead of worrying about writing them down, then if they're in your calculator, your next step is going to be to multiply. So you can just say times 2,000. But I'll just write it down so you have it in your notes there. So last of all is to multiply the 2,000 or whatever your principal is. So however much you invest is going to be 63 times as big. So this time it's going to be 63 times 2,000, but whatever the investment amount was, it'll grow 63 times as big. If you invest 10,000, that'll grow 63 times as big. If you invest $2, that will grow 63 times as big with this scenario. So we have 1,26659.97 or 126,000. So that $2,000 that you invest when you turn 23 in a good mutual fund will grow to 126,000. Now that's an opportunity that declines rapidly as you get older. Let's just say you hold off until you're 30 to do this. So let's do the same problem, but let's say you wait till you're 30 years old. So everything's going to be the same except for t. T will be 30 instead of 42. Why did I just write 32? Well, actually, it would be 35, wouldn't it? Yeah. You're going to leave it in there till you're 65, so it'll be 35. Okay, so we still do the 4 times 35. first. But we already know what's going to happen in here. You're going to have 1 plus 0.025. What's that exponent going to be? 140. So let's see what we're going to be having for multiplier this time. 1.025 raised to the 140. Not as big. 31.72. Yeah, I'll just write down as much as fits, but I'm going to leave the whole set of numbers in my calculator and say times 2,000. But see, before I was able to multiply by 63, this is like half as much that I can multiply by. So quite a bit of difference. Half as much money if you wait, and instead of investing when you're 23, invest when you're age 30, and that $2,000 is only now growing half as fast. Big difference. So that's why I'm telling you this now. Now you could be on the paying end of that instead of on the earning end. If you look at your credit cards, 21%, and you're paying your minimum payments, that's getting you paying this kind of interest instead of earning this kind of interest. So this is a one-time investment of $2,000. Anybody have any questions? Well, let's go back to our Adam and Eve question. First question of the day. So this is the question that you're supposed to finish off, and then you'll be putting a picture in the Dropbox. So we had the Adam and Eve question. You'll need to fill in the formula A equals P times 1 plus R over N to the N times T. Can you go ahead and figure out what all those letters are? Okay, so P, R, N, and T. Figure out what all those numbers stand for in this particular problem. So what was the principal? What was P? 0.01, just a penny. And what was R? Good, 0.03. And what was N? 1. Yep, compounded just annually, so 1 time per year. And T is time, and that was 1,000 years. So we'll fill those numbers in. So remember the order that you do things. First you do the little bit of multiplying that's in the exponent there. Well, you can do the 0.03 divided by 1 as long as you leave it in the parentheses. So that's pretty simple. It's 0.03. And 1 times 1,000 is just 1,000. So what you have inside the parentheses is 1.03. And that's the number that you raise to the 1,000. Okay? You have to do your order of operations correctly or you won't get the correct value. So do the exponent on what's inside the parentheses. Oh, this is weird. What is this? E12. What is the E12? Scientific notation. What does it even mean? the decimal place needs to be moved 12 digits to the right. So it means times 10 to the power of 12. So I move the decimal 12 digits to the right. 6, 8, 7, 4, 2, 4, 0, 2, 3, 1. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When you don't have enough digits, you put zeros there. And then I'm not going to type that in my calculator again. I'm going to say times 0.01. And now I have E10. So my final answer, I have to take and move my decimal 10 places to the right. 6, and then 8, 7, 4, 2, 4, 0, 2, 3, 1. How many decimals? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we'll put in some commas. Oops, wrong spot. So putting the commas helps us figure this out. Okay, so this 4 is in the 400,000 place, and this 7 is in the 700 million place. So this is billion. So 68 billion. $742,402,310. Anybody guess a billion when you were looking at that? All right, good guessing. Good guessing. So interest, compound interest will turn your lead into gold, like Ben Franklin said, and you can be earning it or you can be paying it. Now I have some spreadsheets that I think will be of help for you. So let's go to D12. On the quiz, you need to show the setup, and then some of you have scientific calculators, so if you just show the answer, that's fine, but if you have errors in the way, I can't give you any partial credit. So as much, there'll be some points for this, and some points for this, but if you've made errors to get it here, you won't get any points in between if you don't show that. So it's up to you. Let's look at some spreadsheets that we have in D12 that I think you'll want to download and be able to use in the future. So if you go to D12, to math appreciation, we have under content, if you go to other supplemental material under content, there's 2 spreadsheets that I have for you. One is a mortgage calculator. So I wanted you to see the difference that you get with different mortgage years that you can pay it off in. So download the mortgage calculator. So that's under other supplemental material, the mortgage calculator. So I wanted to show you the difference between paying off a loan in 30 years versus 15 years. So this is a $100,000 loan. The payments don't double when you go to 15 years. You'll especially notice that if your bank is collecting property taxes and your homeowner's insurance, then you'll notice that paying it off in half the time does not double your payment at all. And look at the interest that you cost. You know, you save almost $40,000 in interest here on this $100,000 loan. So when it's time for you to buy a house, here's a similar example of $150,000. When it's time for you to buy a house, just copy this and paste it, and then you can make your decision based on what you see here. You'll have to make this a little wider, it looks like. Okay. And you know, you don't have to buy this fancy house when you first start out. Buy a starter home. Did you know you can buy pretty nice houses in Two Rivers for $50,000? Okay, look at that. How would you like to have a 238? Don't go for that one. Go for this one. How would you like to have a $369 house payment? Right? Okay. You can do that by saving up money or by buying a less expensive house. The other spreadsheet was the budget one. This is a really helpful thing to have. I am embarrassed to say I did not have a budget until I was a lot older than you are, okay? So put in your salary here, maybe as a college student, maybe you don't have that much. Maybe you work more than that though. Let's say for you, this is a monthly salary, okay? So that'll be your income, and then in all the yellow parts you can put your expenses. So, you know, you should have some savings in your expenses. Did you know your car is not going to last forever? You should be saving for a new car, okay? Cars don't last forever. Well, maybe that's too much on a college student payment though. But you can save a little bit for your car. Definitely get an emergency fund. If you don't have an emergency fund, then when your water heater breaks or your car gets a flat tire, you put it on your credit card. You don't want to do that. Build up an emergency fund. So this is a nice budget for you to use. It'll keep track of your savings here. But put all your money into savings that you have extra until this difference is 0. So you have it all accounted for. Take an account for your money. Just don't let it all disappear on you. I'll see you on Friday.